Welcome to True Projects. In this video, we are going to explain about a project titled By Modal Transfer Learning for Classifying Breast Cancers via Combined B Mode and Ultrasound Strain Imaging. So now coming to the introduction part. Breast cancer continues to pose a substantial worldwide health challenge, underscoring the need for sophisticated diagnostic techniques to ensure prompt and precise identification. In recent times, the incorporation of state-of-the-art technologies has resulted in significant progress within the field of medical imaging. A pioneering strategy in this domain is bimodal transfer learning, which integrates B-model and ultrasound strain imaging for the categorization of breast cancers. This innovative method capitalizes on the advantages offered by both imaging modalities, aiming to improve the precision of diagnosis and offer a more thorough insight into the inherent pathology. So now coming to the objective part for this project. The main goal of utilizing the bimodal transfer learning in the classification of breast cancer by integrating B-mode and ultrasound strain imaging is to improve the precision and dependability of diagnostic procedures. Conventional diagnostic approaches frequently hinge on a solitary imaging modality, potentially offering an inadequate or restricted understanding of the inherent pathology. This study seeks to create a more thorough and nuanced method for classifying breast cancer by merging the advantages of B-mode imaging, known for its proficiency in capturing anatomical details, with the dynamic insights provided by ultrasound strain imaging, which evaluates tissue stiffness. The objective is to move beyond the limitations of single modality imaging and enhancing the overall accuracy of breast cancer diagnosis. So now coming to the requirements part, here we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 8 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow project, here first we have importing the packages. In this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate machine learning, and Matplotlib and C1 for visualization are important. Second, then we have data exploration, that is B-mode dataset. Examining and understanding the B-mode dataset, which likely contains images or data related to breast cancer. This step aims to gain insights into the structure and characteristics of the dataset. Then we have image processing, utilizing image data generator for augmenting and enhancing the dataset. This involves operations such as rescaling images, applying shear transformations, zooming, horizontal flipping, reshaping the images. These techniques contribute to improving the model's ability to generalize from the training data. Then next here we have data extraction into training and validation set. Splitting the dataset into training and validation sets. The training set is used to train the machine learning models, while the validation set helps assess the model's performance on unseen data. Then we have building the model, creating various machine learning models for breast cancer classification. The list includes popular architectures like ResNet 50, Inception V3, QuizNet, VGG16, VGG19, Inception ResNet V2, MobileNet V2, DenseNet 121, DenseNet 169, DenseNet 201, DenseNet 50 V2, DenseNet 101 V2, DenseNet 152 V2, AlexNet, and an ensemble model combining with MobileNet and AlexNet. Then here we have training and building the model. Training the machine learning models using the prepared dataset. This involves feeding the training data into the models, adjusting the model's parameters, and iteratively optimizing the models to achieve the better performance. Then we have Flask framework, localhost sign up and sign in with SQLite 3. Implementing a web framework like Flask to set up a local server. This includes creating functionality for user sign up and sign in, and utilizing SQLite 3 as a lightweight database for user information storage. The next here we have user uploads the image for analysis, allowing users to upload images for breast cancer analysis. This involves creating an interface where users can submit their images through the web application. And then next here we have the given images process, that is using Keras image to array and reshaping the image. Processing the user uploaded image using Keras to convert it into an array format and potentially reshaping the image to match the input requirements of the trained models. Then we have trained model, or model is used for predicting user data, employing the trained machine learning models to make predictions on the user uploaded data. This step involves passing the processed image through the selected model. And then we have predict with model for outcome, utilizing the model to predict the outcome of the breast cancer analysis based on the features extracted from the user uploaded image. And then here we have last, displaying the final outcome, presenting the results of the breast cancer analysis to the user through the web application. This could include displaying the predicted outcome, probability scores, or any relevant diagnostic information. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder which is named as templates. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Then we have folder which is named as static. This folder consists of files related to CSS, JavaScript, and Bootstrap files. Then we have the folder which is named as data. This folder contains of the data set which is used in this project. Next here we have .ipynb file, which is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows the users to write and execute code in individual cells, making it a popular choice for data science. Next then here we have the app.py file, which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML template. And the last one here we have signup.db file. This file appears to be the database file which is used to store the information. So now just click over here and copy the path. Open the Anaconda prompt. Type the cd command followed by a space and just paste the path over here, and now hit the enter button. And now type python app.py. And now just hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 unless configured differently. So here you can see that the link has been posted over here. Just select this link and copy this link and paste it into any of the browser. Here I am using Chrome. Just paste the link over here and now hit the enter button. So here you can see that this is our home page for the breast cancer. So it is showing like about the breast cancer, the image processing, and the deep learning. So here you can see that there is a button for sign up. Just click on it. Enter your username, your email ID, your phone number, and your password for doing the registration. I have already done the registration, so here I am clicking on sign in button. Just enter the username and the password over here which you have created while doing the registration, and simply click on login button. So here you can see by scrolling down below, it is showing that upload your image to be classified. Just simply click on the choose file button and click on and choose any image from this. So here I am choosing the first image, and now simply click on open button and now click on upload. So here by scrolling down below, here you can see it is showing the result as beginning stage of cancer. So depending upon the image you are uploading over here, it is showing about the breast cancer. It will predict the breast cancer. So it is showing the left breast. Let's click on try again button and upload some other image and try with that. So suppose here I am choosing this image and now click on open button, and now here click on upload. So here you can see the image which we have uploaded over here. It is again showing that beginning stage of cancer. Depending upon the image you are providing over here, it will detect about the disease type. So here you can see that there is a button for graph. By clicking on this graph button, here you can see that it is showing many different graphs and the algorithms which we have used over here. Depending upon the algorithms, it is showing the accuracy. By clicking on the predict button, you can just upload your image over here and just predict the type, breast cancer type. And here you can see that there is a button for sign out. Just click on this button and you can successfully log out with this. So now coming back to the conclusion part. In summary, the utilization of bimodal transfer learning for breast cancer classification incorporating B-mode and ultrasound strain imaging presents a compelling avenue in the realm of medical imaging research. The model created by merging the intricate and anatomical details from beam mode imaging to the dynamic evaluation of tissue stiffness from ultrasound strain imaging strives to provide a more refined and precise classification of breast cancers. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.